Hi, everybody, and welcome. This is day 61 of the 100 Days of Labbing Journey. And I just finished watching Duan and Antonio over at Lab Every Day. And I just felt so inspired again. Although I feel like all my energy is drained because it's nearly midnight. And I'm just finishing up studying. So I am a little bit drained, but here we are. So I wanted to come back with a small update, sort of a part 2 of my redistribution problem that I introduced last video, which was let's see, tonight is Thursday, which was Wednesday night, and that was redistributing in between IGPs, mutual redistribution between IGPs, when you're also redistributing interfaces as external to a protocol, and sort of how that affects and what the dynamics are of the IGPs at that point. So I have a little lab stood up. I'll do a quick whiteboard to kind of try to introduce the topology, and then we'll dive in and we'll redistribute our protocols, and we'll see what we have on both sides. And then we'll introduce a redistribution, an external redistribution, and see how that affects everything. And then we'll do it and we'll flip the protocol and see how that changes things. And I think this will help to explain it. At least I have a passage here that I'm going to read that came from an INE workbook. It's just a couple of sentences, but I think it best describes it. And another member of the Land Tamers community, if anyone wants to join the Land Tamer Discord server, there's a link, there's an invite link below. It is a chat server where a lot of us who are working on certifications or just into networking, where we can do live chat all day, every day. And someone in the chat, Mr. Alex Murray, helped me out by pulling this, extracting this out of the INE workbook, in which I've seen this. This is a lab that I did a few months ago. And I remember reading this passage, and it didn't make sense to me then, and it didn't make sense to me until now. So I'm going to go over it right now if I can. Let's see. Let's open up a whiteboard and talk about the topology. Okay, so here is my my topology. Although these routers are called VIOS 4, 5, and 6, they are actually router 1. Excuse me, I'm not going to put it like that. This is router 1 here, router 2, and router 3. And I'm going to outline some routing domains. So we're going to go ahead and make this one. This is going to be EIGRP. And then I'll use another color for what we'll do as OSPF. Also, I want to mention that each router has a loopback interface, which I'll draw as a little stem, and that is loopback 0 on all of these routers. Same topology I was working with the other day. The other day I did it in GNS3. Today I'm doing it in EVE-NG, just because I like to flip back and forth regularly. So what I have here is, actually, let me redraw these boundaries, because I actually did something different, just because I wanted to see how it would end up. So if I draw the EIGRP boundary again, the EIGRP boundary is going to be that link. The OSPF boundary is going to be just the directly connected link. And what I did here is I redistributed loopback 0 into OSPF on router 3. And I redistributed loopback 0 into EIGRP over on router 1. And also, here between the two protocols, I'm doing a mutual redistribution. So right now, router 3 should be able to see and ping this link and the loopback. It should have full reachability. And likewise, router 1 should be able to see this link and be able to ping the loopback, and should have full reachability across the topology. So I'll just go ahead and pull up the devices and show that now. Here on the bottom right-hand corner of the screen, we have router 3. On the bottom left-hand corner of the screen, we have router 1. And up here at the top, in the middle, is router 2. So over on router 1, if I show IP interface brief, just to show you the interfaces, I have our connected interface as well as our loopback. Our loopback is the quad number of whatever the router number is. Here on router 2, same thing, show IP interface brief. We have a loopback, which is 2222, a subnet that joins over to router 1, and a subnet that joins over to router 3. And show IP interface brief. Same thing over here, a quad IP address for the loopback and a connected interface. So I am doing mutual redistribution here, show run, section, router. I think I might be able to show both routing protocols. So I have router EIGRP. I'm including my directly connected interface, and I'm redistributing OSPF in. And for router OSPF, I'm using interface configurations. So that would be show run interface gigabit 01. And OSPF process ID 1, area 0. And again, in OSPF, I'm redistributing EIGRP and including the subnets. So right now, router 3 and router 1 should both have full reachability to each other's loopback and the directly connected interface. On router 3, I'll do show IP route. And you can see I can see router 1's loopback as well as the connected interface on router 1. I also see my own information, so I'm not going to bother highlighting that. And on router 1, show IP route, again, I'm going to see router 3's loopback and its connected interface as well as my own connected interfaces. And because this is being redistributed into EIGRP, we're seeing them, as you can see here, identified by the EX for external routes. Both the directly connected interface and the loopback are seen as external, and over on router 3, router 1's loopback and the directly connected interface are also seen as external, as identified by the E2. On router 2, we should have a full routing table of the entire topology, including router 2's loopback. Right now, router 2's loopback is only on router 2. I did not redistribute that into any protocols, so no other router is seeing that. But router 2 does have the 2 connected interfaces and does see the other loopbacks. So at this point, we should be able to ping 1.1.1 source from loopback 0. Right? That's to be expected. This is a basic, this is probably your CCNA level redistribution. It is certainly a CCNP level, but I think at CCNP they start to introduce some filtering while doing redistribution. So the problem I'm going to introduce here was one that I've seen in a number of CCIE prep labs that I've been doing, and I had yet to really sit down and be able to predict what the effect is going to be. And what I mean is, let me go back to the whiteboard. If I can. Back to the whiteboard here. What I want to do is next I want to redistribute loopback 0 on router 2 into OSPF. This is a common scenario in a CCIE prep lab. There's always a ton of redistribution. So my being a CCIE student, right, someone who's learning this, I want to be able to look at this topology and already predict exactly what I should see in router 3's routing table, how will it affect router 2, and how will it affect router 1, right? What will I actually see? So if anyone is watching now or watches this later on after it goes live, can you predict what you'll see? So I've done this just a short while ago, and I did it as a test to be able to prove to myself my hypothesis was correct. And I'm going to read the passage that someone shared with me. And again, this is from an INE workbook. It's just a couple of sentences, and it says, when explicit connected redistribution of specific interfaces is done into a protocol on a Cisco IOS, and another protocol is also being redistributed in addition to connected, the connected interface of the second protocol will not automatically be redistributed into the first protocol. The connected interfaces of the second protocol must be manually accounted for in the connected redistribution into the first protocol. Now understand that is a lot of back and forth, and that's a lot of first protocol, second protocol, first protocol, second protocol speak, which is why I found it so confusing to begin with. But after sitting here and labbing it up incorrectly last time, and then now labbing it up what I believe correctly this time, I think I have the answer here. So what I'm going to do is redistribute only loopback 0 of router 2 into the OSPF routing domain. And so that way only router 3 should see the loopback number 2. But how will that affect the routing domain on router 3? And how will that affect the routing domain on router 1? So I already have a route map here. So if we do show run partition route map, you can see I have a route map called redist. I have only a single statement, a permit statement, and I'm matching only a loopback interface. So I'm going to go ahead and go under the OSPF stanza and do redistribute connected. I want to redistribute my connected routes, but I want to filter it through the route map redist. And I know filter is not the preferred nomenclature for this because filter can do something else in other protocols, but that's just how I read it to myself. Redistribute the connected interfaces, filter those connected interfaces through the route map redist, and here I'm going to include subnets so they don't become classful. Hit enter. Okay. So there should be no change on router 2's routing table because it'll always be a connected route. So I'm going to come over here to router 3, and I want you to take a look at the existing routing table before I refresh it. I see the loopback on router 1. I see the loopback on router 3. I see the connected interface in between router 1 and 2. And of course, I see the connected and local interfaces here on router 3. So as soon as I do up arrow twice and do show IP route again, the routing table changes. If you haven't done this before and you don't know exactly what to expect, if you have at least a CCNA level experience and CCNP level experience, you would have probably predicted that we would see the loopback of router 2, right? That is what we are redistributing into OSPF. We still see the loopback of a router 1. We still see the loopback of router 3. Obviously, it's directly connected on router 3. But you see something's missing here. And what's missing here is the upstream connected network, right? The connected network between router 1 and router 2. Now that is an EIGRP, that is in the EIGRP domain. And if I just scroll up to show the routing table previously, you'll see that that was an external route, which means it was being redistributed from EIGRP into OSPF. However, we don't see that anymore. Now, we didn't do anything with changing the redistribution of EIGRP into OSPF on router 2, but that prefix is gone. And the only thing I have to rely on is the couple of statements from the couple of sentences, like I said, from the INE workbook. When explicit connected redistribution of specific interfaces is done into a protocol, that's what we just did here. We did an explicit interface, which was loopback 0 into OSPF. And another protocol is being redistributed in addition to connected. So we're also redistributing from EIGRP. Let me see if I do the whiteboard. So this is our explicit redistribution into a protocol, and we are redistributing from EIGRP into OSPF. The connected interfaces of the first protocol will not be, of the second protocol will not be seen in the first, right? So that's exactly what it is. Over here on router 3, we are no longer seeing this interface. It's gone. So if I come over on router 1, let's check to see what changed. Here is the existing routing table. I'm going to up arrow just to see what changes. Nothing changes. EIGRP, the routing domain of EIGRP is not affected. So what I'm going to do now is I'm going to remove this redistribution into OSPF, show the routing table in both routers 1 and 3, show that they're stable and everything is reachable, and then I'm going to redistribute that loopback into EIGRP and check the tables again. So I'm sort of going to flip the redistribution. So for this, we'll do conft router OSPF1 no redistribute connected. Okay. So let's show the routing tables here, show IP route and show IP route. And again, we're back to normal. We no longer see the loopback of router 2, and we do see the connected interface upstream between router 1 and router 2. And there was no change here on router 1. Okay? So now I'm just going to take the same redistribution statement I used into OSPF and put it into EIGRP. We're going to redistribute connected. I'm going to filter it through a route map called redist, and I'm going to go ahead and set the metric value to 1,100, 255, 1, and 1,500, which just fills in the values that we need. Hit enter. Now, with what we just saw and what I've just read, the prediction I would make at this point if I can sort of clear off some of this stuff. The prediction I would make at this point, right now I'm taking loopback 0, redistributing it into EIGRP. Previously, there was no change to router 1 or router 3's routing tables, so now if I was going to predict what would happen, I would say that if I'm flipping the script on this, router 3 would have no change, and the only change should be on router 1, and we should see the loopback of 2.2.2. I'm going to put a plus sign. We should see that, and we should not see the link between router 2 and router 3, which is, in this case, 20.1.230.24. Let's see if this is taken away and if this is added over on router 1. I'm trying to make this predictable, right? That's one of the things about, I think, about preparing for and passing the CCIE lab exam, or really just any exam. I mean, even in your professional career, for most people sort of at the CCNA level, they might not have much of a professional career yet. So you're expected to sort of learn and study and everything. But when you're at the CCIE level and you're given a simple redistribution scenario, I think you should be able to visualize exactly what's going to happen and predict exactly what's going to happen before it even happens. So again, let's get over here on router 3. Here's the existing routing table. I'm going to go ahead and do a show IP route again. Right? I'm seeing my directly connected route. I'm still seeing the upstream prefix redistributed from EIGRP into OSPF, and my local loopback in router 1's loopback. I am not seeing the loopback from router 2. Over here on router 1, taking a look at the existing routing table, I'll up arrow to update it. And so now we're seeing the added prefix for router 2's loopback, and you see we're missing the prefix now, which is between router 2 and router 3. So that behavior seems to be exactly what is described in the few sentences of the INE workbook. I hadn't seen that sort of worded anywhere else. I don't know if there's a better way to describe that. I might write my own little description of that, but it would essentially be taking exactly what's in the INE workbook and just turning it into my own words for myself. But I was really kind of stuck on this before, and I think one of the challenges before was I was running RIP before, and I had the major network 10 on both sides of router 2. So I was always including both interfaces in the RIP updates. And that was just extra confusing. And that's okay. I'm glad I experienced that, because oftentimes, you know, I've said many times on stream that, you know, I think a lot of people in their studies don't really give RIP enough due time. They think, oh, it's this old protocol, I just need to know the basics, and they can just get through it. But really, there's some subtle nuances in its behavior that you have to know, and you have to be able to predict the behavior. So this is with OSPF and EIGRP, this experiment. I think what I'll do right now is I'll go ahead and do this with RIP. I'm going to replace EIGRP with RIP. Conft, I'm going to say no router EIGRP1 over on router 1, conft no router EIGRP1. And instead I'm going to do router RIP. I'm going to call it version 2. No auto, and I just want to see the same behavior. And next I want to do network 120 and also redistribute connected route map, because I do have this external loopback. Every router has its own loopback, and I'm redistributing it into the protocol, and we'll set the metric at 1. Now over here, router RIP, let's do version 2, no auto, and let's turn it on for our connected interface. Now over here I should do show IP route, and I should see the loopback of router 1 as a RIP route with a metric of 1. That's good. Okay, so now I want to do redistribute connected, filter it through a route map, which is called redist, and set the metric of 1. So now I've just redistributed the loopback number 2 into the RIP routing protocol, and I'm seeing that now. And again, oh, you know what? I'm not doing mutual redistribution, so let me do redistribute OSPF 1 metric 1. I'm not seeing the loopback 3 here, so let me just do an up arrow, see what gets updated. So now I do see the loopback of 3. And again, the same behavior that we saw between EIGRP and OSPF. I'm not seeing the interface between router 2 and router 3. Right, that is not getting redistributed here on router 2. So router 2 is not bringing that connected interface in. So the solution to this problem is being able to recognize what is the default behavior. Right, because what I have found in the CCIE prep labs and a lot of the study material from the different vendors is they will try to back you into a corner a little bit. They will try to make you make this mistake, right, by giving you a task later on that says, now redistribute the loopback of router 2 into the OSPF protocol. Next, make sure all interfaces are reachable throughout the topology. Well, if we were to do that now, they wouldn't be, right? Because router 1 doesn't know how to reach the upstream interface in between router 2 and router 3. So it would actually back you into the corner, and the whole purpose of this exercise is being able to look at the topology, look at the tasks, right? I know this is a redistribution task, I already have it in my head, but be able to predict the behavior before I even lay hands on keys. And then, is there another command there that they're not telling you that you need to run, but that you should know it based on experience? And that would be including route map, redist, and match interface loopback 0, and also gigabit 01. I don't know if I have to clear the routing protocol for it to update. I did not. It already updated. So now that I just added that upstream interface, now we can see it. So the next logical task in a lot of the CCIE lab preps that I do would say, now make sure all of your interfaces are reachable. They didn't tell you you needed to match both interfaces. They said only redistribute the loopback 0 interface of router 2. But you should know that when you do that redistribution, you'll also need this to maintain reachability throughout the topology. So again, that was something that was always throwing me for a loop, and especially the lab I did on Wednesday. What was throwing me for a loop, in addition, was on both sides of router 2. Show IP interface brief. Both of these interfaces were in the 10 address space, and so if we look at show run partition router rip, you can see it does a sort of a classful network entry. Even if you put in something more specific, it still puts it in a classful entry and will include all the interfaces in that class, which would include both interfaces. So I was not seeing this behavior the first time. It was kind of strange. So guys, that's my study for tonight. Again, I'd like to thank Duan and Antonio for providing such great support to the community and energizing the community, and you guys motivate me as well. It's really a lot of fun to be part of this group. Oh man, I had the chat back here, and I didn't see that Aaron's watching me. Hey Aaron, great to see you here. This plus that. So order matters when redistributing. So is it the most recent redistribution override the previous or overwrites? No, it's not. It's not the most recent overwrites. And what happens when you redistribute the loop back first? The same thing happens, yeah. So it's not an order of operations problem that we're trying to solve here. It's a connected interface problem. And I can't actually describe or answer the question to why this happens. I can't tell you why this happens. I don't actually know what's going on under the hood in iOS of why this decision, or why this is the effect. But because I would assume that so here's my assumption. Actually, this is a good opportunity. Let me go back to the whiteboard and kind of just do my assumption here. Okay. So let me blank this out a little bit, give myself a little bit of drawing room. I really had a lot of fun working through this, and I hope that tonight's lab is going to help me in doing labs in the future and being able to quickly diagnose exactly what needs to happen prior to configuring it. So the very first scenario that I did, I took loopback 0 on router 2, redistributed it into OSPF, and what we found was it was exactly a true statement from INE, which was router 3 then no longer sees this upstream link between router 2 and router 1. It no longer sees it in its routing table. If I was to make a prediction prior to seeing this behavior and trying to understand it, I would say, well, wait a second, this link is an EIGRP link, right? It's in the EIGRP routing domain. And we're redistributing EIGRP into OSPF, so why doesn't router 3 still see it? And I think that stems from here on, even though this says iOS 5, it's not, it's actually router 2. Here on router 2 doesn't see this connected link as an EIGRP interface. It sees it as a connected interface. And so I think that's where the override happens. Again, I'm just trying to sort of explain it to myself in my own words so I understand it. But from router 2's perspective, this interface is a connected interface. It's not an EIGRP prefix. So if you look in router 2's routing table for any directly connected interfaces win with an administrative distance of 1, right? Uh-oh. How could I forget something so stupid? Directly connected. What is it? Is it 0 for directly connected? I guess so. I'm trying to think now. Oh, and 1 for a static route. Let me just put a static route in. I'm sure everyone's just sitting back laughing at me failing about this. That's okay. Conf T. Without a next hop, so I'll just fill that in. Right now I'm just testing my theory on is directly connected. It's directly connected. Okay, well I don't get to see it there either. Okay, but anyhow, before I go off on a tangent. From router 2, again, what I wanted to say was router 2 doesn't see any of its upstream links or downstream links as their routing protocol. Instead, it sees them as connected. And I think that's the difference, right? On route, and it's all on router 2's decision. Even though it is, so if I do show IP EIGRP, I think Topology, I'm not running EIGRP, so let's do show IP OSPF database. We do see the connected link, the connected interface here. And if we do show IP OSPF database for the router LSA, we see the connected interfaces here. It's because even though it is in the OSPF database, router 2 doesn't see it as an OSPF route. In this case, show IP route. It sees it as directly connected, and I think that was what the override is. No adjacency, yeah. A binary, let me know when you find that clip from the video. I would love to find out when the hell I found that out. It was late in the lab. I don't know if you remember watching the video, but I had, we were talking about my lab from last Sunday, Aaron. I kind of skipped that link, that adjacency. I was just like, you know what? I don't know what's going on. I'm troubleshooting this thing for way too long. And I actually skipped it. And it wasn't until later on in the lab where in another task needed that adjacency that I went back. And I think it was the timers. And it was the timers, I think, because of the network types. I'm trying to think, what was it exactly? I think one of them was a point-to-point, one was point-to-multipoint. I don't think I checked the timers. I think I checked the network type, and I saw that it was a compatible network type, but I didn't check the timers. But I could be wrong. Binary, I don't know how many labs you've done, but my memory for these labs has just all become a mixing bowl of zeros and ones, and it's hard for me to distinguish one lab from another. In fact, I was looking over I still have my printout, my paper here, which is, and I was looking at the lab tasks. I know this is the lab I did last weekend, but I couldn't find out where I left my notes for the adjacency, which was somewhere here, OSPF, spanning tree. Why does non-broadcast be priority 1, be priority? I don't remember. I couldn't find it in my notes. I could not find it in my notes. But anyhow, by the timers, do you mean the hellos and deads? Yes. Yes, the hello and dead timers, yeah. I think that's what it was. I think it was the hello and dead timers. You know, too bad Google doesn't have like a smart enough algorithm to look over my video streams and that I can just search content from within the streams. Wouldn't that be nice? They probably do, but they won't let us search it. They're probably just mining it for their own good. Anyhow, guys, that kind of wraps up my lab tonight. I think we did a pretty good experiment here of redistributing IGPs between the two protocols and being able to predict the effect with accuracy. So now when I see this sort of topology and this sort of redistribution problem, I'm going to be able to predict with some accuracy what's going to happen, you know, just based on my experimentation here and the explanation that I pulled from, or that was given to me from INE. And that explanation came from the Foundation Lab number 2. So if anyone buys the INE workbook, it is one of the Foundation Labs as part of the CCIE route switch workbook that they have. Is really awesome lab, and I remember reading that a few months ago when I did that lab. but I didn't understand it then, and it's not till now where I'm really starting to understand it a little bit. And I think I'm going to continue this redistribution journey, and the reason is because many labs call for redistribution, and there's a lot of time where there's a mutual redistribution between two protocols in two different points, and that can also lead to some routing loops, and I think nearly every time I almost have a routing loop. So again, I want to be able to predict the behavior when I see this kind of topology, which is here, as well as a mutual redistribution between routing protocols across multiple points. I want to be able to predict the behavior with accuracy then as well. So guys, I hope this was a good enough explanation. Thanks for popping in, Aaron. Thanks for popping in, Binary. Anyone else out there watching, I really appreciate it. And I'll be not labbing tomorrow, but I will be labbing Sunday. I think I'm going to work on some troubleshooting labs on Sunday. And I hope to see you all there. So I'm going to start probably bright and early in the morning on Sunday, probably around 8 a.m. Eastern time on the U.S. See you guys. Good night.